Hello everyone and welcome to this talk titled Project Cassini, Ensuring a Secure Cloud-Native Experience at the Edge. I'm Augustine Phillips, Director Segment Marketing within the Infrastructure line of business at ARM. And for this talk, we will be joined by Rob Dimond, who is with the Architecture and Technology Group at ARM. So let us start by exploring some of the key trends in the vast technology space that is the edge. That is the world between billions of endpoints and the hyperscale cloud. These trends that are shaping data collection, processing, and management strategies for a broad range of industries and associated service providers. So the world of endpoints can be associated with unprecedented amounts of data. So this is expected to run into as many as close to 10 trillion data streams by 2035. So these streams all get processed along various aggregation points on its journey to the hybrid cloud and back. Whether it is a converged IoT gateway in a smart factory or an intelligent node handling tens or hundreds of HD camera streams in a smart cities installation or even a software-defined car even, all these processing domains are evolving to essentially become optimized compute platforms. And further upstream, we see an increasingly open and disaggregated and virtualized, either wireless or wired network infrastructure being installed. And some examples are industry initiatives like ORAN or HCMEC and early deployments of UCPE. So now, enterprise networks are also being designed to react autonomously to changing business intent to consistently deliver on service level agreements. Underpinning these trends is a management approach based on cloud native software principles. And now they are being extended into the infrastructure and IoT edge. So this edge is closely associated with heterogeneity. And this is an attribute that is essentially second nature to the ARM ecosystem. Now, the challenge, and in fact, the opportunity in front of us then, is to ensure that enterprises across these industries are not having to compromise in their choice of platforms. A homogeneous approach at the edge simply does not work. So, how do we merge these two worlds? One of diverse, vibrant hardware and the other of cloud-native software in a secure manner. Something that we believe only the wonderfully capable world of the ARM ecosystem is well positioned to deliver on. And this is why we announced Project Cassini last year at the ARM TechCon. So Project Cassini is an open, collaborative initiative to ensure a cloud-native experience across a secure ARM-based edge ecosystem. So it is composed of three foundational pillars that promote a standards-driven approach to hardware, to firmware, and security, and jointly validated with a cloud-native software stack deployed at the edge. So let's look a bit closer into what Project Cassini entails. Robust hardware and firmware standards are advocated through the ARM SystemReady program. SystemReady is a foundational certification program with a vision of enabling software to work seamlessly across a vibrant, diverse ecosystem of hardware. It builds on the existing ServerReady program and sets the standards for a broader set of devices, initially targeted at the infrastructure and IoT edge segments. Secondly, for platform security, industry standard security guidelines and APIs are promoted through PSA Certified and PARSEC. As the third pillar, reference solutions that are developed in close partnership with our ecosystem serve as building blocks for a truly software-defined cloud-native edge. And to take us through the various pillars of Project Cassini, allow me to hand over to Robert Dimond. Rob?
Hi, thanks Nebu, and thank you for joining this presentation. So I'm going to talk in a bit more detail about what Cassini is, so the different components, and also give some examples of how Cassini is being used. So Firstly, Cassini is applicable to a very wide spectrum of devices at the edge. So this slide is showing a simple high-level model of what's in scope for Cassini in terms of platform and software stack. So firstly, we think of Cassini platforms as being connected to a network and managed. So there is an edge runtime, a software stack on the device, which connects to a management service, could be public, private cloud, or on-prem, and deals with update and an install of applications onto the device. There's a general purpose operating system, so not an RTOS, so an OS that requires an MMU, the A-profile architecture in an ARM world. We're doing some exciting stuff around M-profile software, but that's not in scope for Cassini. Support for virtualization in the broadest sense. So this could be containerized software or virtual machines, and a hardware root of trust. And really what that means is that because these devices are connected, they're going to need various secrets in order to authenticate themselves to services and other platforms. And those secrets need to be protected from a compromise of the operating system, so maintained in special purpose hardware or a firmware environment, for example, and software defined, so modular software and hardware. You're using that virtualization to install new functionality onto the device. So a bit more detail on the components of Cassini. So there'll be a lot more information on SystemReady at this DevSummit, so I urge you to check that out. SystemReady is really taking what we've learned from going into the server market and building a server-ready program. So the server market required modular hardware and software with the interface defined by industry standards. And we're looking to bring some of the same benefits to a broader market. It's very much opt-in. So really what SystemReady is doing is providing a language for software vendors and OEMs to describe their requirements, and then SystemReady is providing tools to actually test against those requirements. So the differences from server-ready, well, we're recognizing that different standards are used in the embedded world, and the value proposition is, and the nature of the market is different. So it's about reducing the cost of maintaining a custom operating system distribution, or allowing use of an operating system kernel that's maintained by a vendor who's then amortizing the cost of security updates and so on across multiple customers. So there's really some unique changes to extend server-ready into this broader market. The second piece of technology is around security, and we've really built multiple components here to address different challenges that we see in this market. So so the root of trust is the part of the system that can't be cryptographically verified. The very basic bootstrap of the security of the system. And unless you're deploying a device and you're completely vertically integrated, then you're relying on varied root of trust implementations from your silicon vendor or firmware vendor and so on. And you have to answer the question, well, is the security engineering that's been done, is it a good basis for building a product that's compliant with various government regulations and industry standards? And to do that, to address that challenge, we're essentially evolving PSA Certified, which was established around constrained IoT endpoints a few years ago, to apply to these platforms with the more with the software stack on the previous slides. The second challenge is around interfacing to system software. So you know, the benefit that you get from SystemReady on the previous slide is that you can deploy an operating system without having to do significant platform-specific engineering work. And you know, we don't want to break that by enabling security features. So security capabilities such as secure boot, those you know, for ease of deploying system software, they need to also be implemented according to industry standards. And so there's a security profile in SystemReady which does exactly that. So it defines some requirements around secure boot and update according to the UEFI standards, and then, you know, as with the other components of SystemReady, there will be a compliance story to test against them. And then the third challenge is really a broad industry problem, which is that, you know, the great thing about containers and cloud native software is the sort of build once, run anywhere approach. You know, you don't care about the underlying hardware, it's abstracted. Well, there's a dilemma when it comes to security, because the best security is rooted in hardware. And so how do you use that hardware security without plumbing platform-specific code into your apps? And we're contributing to a project in the CNCF, the Cloud Native Compute Foundation, which is PARSEC, and that is a root of trust abstraction that for cloud native apps that supports you know, many different potential implementations underneath the API. So the third component that Nebu introduced was around cloud native ecosystem. So the cloud native ecosystem on ARM has made enormous progress over the last couple of years. It's been driven to a large extent by ARM servers being available in the cloud, and developers wanting to use the same tooling on those ARM servers. So AWS are now on their second generation of Graviton instances. So just to highlight a few of the most important components, you've obviously got Linux OS distributions, and then key languages and runtimes that developers are using to write their software. Then you've got various components of container infrastructure for packaging applications, and then the applications themselves, so workloads. So Nginx is one example that's been demonstrated recently to show 50% perf benefits and 20% cost benefits on the AWS platforms that I mentioned. So that is really driving the porting and optimization of these workloads on ARM that are then equally applicable to edge platforms. And then there's CI/CD, so continuous integration and continuous delivery tooling. So one of the things I think that's most exciting about Cassini and bringing cloud native to the embedded world is being able to use the tools and processes that have been developed around cloud services for updating and deploying applications. So those are the components of Cassini. I'll now talk a bit about the examples and how we see these components being used. So one example is UCPE, or Universal Customer Premises Equipment. So customer premises equipment, that's really the router or router box that provides internet and WAN connectivity to home or enterprise. And traditionally, CPE is a fixed function device, limited functionality, and it's a truck roll to deploy new capabilities to that device. And UCPE is really a great example of a Cassini opportunity, because it's software defined. You have the ability to take cloud native functions and deploy them for security and other value add services. And Cassini is really enabling this on diverse ARM platforms that ultimately gives you better performance, lower cost, lower power, or a combination, by combining this rich software ecosystem and consistent software ecosystem with then diverse solutions and silicon. So another example is an embedded ODM. So typically, so these are providers. They maintain a portfolio of platforms that may go into IoT gateways, industrial devices, and the like. And the feedback that we often get is that their customers prefer ARM-based solutions. But the out-of-the-box experience can be a challenge. There may not be as much choice in operating system, and there may be some custom engineering work to deploy an OS and use the capabilities of the platform. So the tools in Cassini, so SystemReady for deploying an operating system, PSA Certified to build confidence in the quality of implementation of the root of trust, and PARSEC as an abstraction is really enabling scale for these ODMs and giving customers choice in the software that they deploy. Another example to highlight is some joint work that we're doing with Rancher, and they've been able to demonstrate a continuous integration and continuous deployment flow using an ARM-based edge device, and that flow is built using K3s. So K3s is another open source project that's just been accepted into the CNCF, and it's a pared down Kubernetes distribution, so suitable for deploying and orchestrating apps onto a more constrained edge platform. So again, I mean, I think this is really the exciting thing about the idea of bringing these cloud native flows to the embedded world, is having a flow for a developer to commit their code, it gets built, and then there's an automated deployment path to the end devices. And the final example that I'll talk about is VMware and ESXi on ARM. So the SystemReady component for Cassini is really quite fundamental for taking this essentially enterprise software stack with really data center grade features, high availability and fault tolerance, and being able to deploy those on a really wide range of devices. So smart NICs, a device embedded even in a wind turbine, and it's really exciting. I think the opportunities that come from that combination. So at the far edge, being able to reuse that technology around reliability and recovery to minimize truck rolls out of that device. The ability to use virtualization to consolidate workloads onto a platform like a CPE, and it really scales up to the near edge. So think of classical 19-inch servers, but power optimized and deployed close to where IoT data is being generated. So to wrap up, I'll hand back over to Nebu to talk about the value proposition of Cassini and how to get involved.
Thank you, Rob. So as we have heard, Project Cassini is created for and in partnership with our ecosystem. So there is just no other way this works. So for silicon partners, for ODMs, for OEMs, so Project Cassini unlocks new markets. So all the while maintaining existing differentiated industry-leading positions for our partners. So there is no longer a need to make a choice between ease of use or the right platform for the workload. We can have both. For independent software vendors, for application developers, for system integrators, and end enterprises, Project Cassini reduces the cost and friction of supporting a broad swathe of ARM platforms and enables support for diverse solutions, all the while leveraging existing software investments. So how do we engage on Project Cassini? So depending on your priorities, there are many different ways to engage. So it's opt-in by nature and provides flexibility by design, and it offers a host of benefits across the partner spectrum. So here you see a few suggestions for which pillars of Project Cassini might appeal across a broad spectrum of our partners. ARM invites you to explore the various ways Project Cassini might benefit your edge deployment priorities, whether it be through the ARM SystemReady program, or PSA Certified or PARSEC, or through joint multi-party proof of concepts. We as ARM are excited to stand with our partners to deliver on the vision behind Project Cassini. Please tune in to related talks at this DevSummit, especially for ARM SystemReady as well as PSA Certified, along with a few of our partner sessions. Thank you everyone for watching and hope you have a great DevSummit. Thank you.